So xk will be wn matrix into xn matrix. Therefore xn will be inverse of wn and xk. Okay, and because wn is a square matrix, therefore wn inverse will be this. Okay, and we last time defined wn as this also. Okay, wn matrix 4 into 4 का जो matrix होगा, it will be given by this matrix. This is xk matrix, this is w matrix, and this is xn matrix. So when we find out its values, these values will be 1 1 1, and this will be this matrix. Okay, and by complex multiplication we can find out its value of xk by complex multiplication. Okay, third here, xn can also be found out by inverse DFT, inverse DFT. If xn is given, we need to find out xk. So what we will be doing? We will be doing the complex multiplication of this. This means this matrix, W matrix, multiplied by xn matrix 4, 2, 0 and 4. This matrix. This will give you xk matrix. xk matrix. So what will be its value? बताइए क्या होगी इसकी वैल्यू? Okay, so this will be your xk after matrix multiplication. This will be your xk. This will be your xk. यानी कि xk will be 10 4 plus 2j minus 2, then 4 minus 2j. This will be your xk. Okay, 10 minus 2j minus 2, 4 minus 2j. DFT of complex conjugate of xk will be this matrix multiplied by this matrix. यानी कि 10 4 minus 2j minus 2 4 plus 2j. इसकी वैल्यू बताइए. So it will come out to be 16 8 0 16. I hope सबका आ गया होगा. Okay, so by using this we can find out xn also. So xn will be 1 upon n. ये हमने find out कर लिया. Now we have to find out its 1 by 4 लिख सकते हैं सीधा ही 1 by 4 एंड इसका कॉम्प्लेक्स कॉन्जुगेट. ये है DFT और फिर DFT का कॉन्जुगेट. पहले इसका कॉन्जुगेट लिया, फिर DFT निकाला, फिर उसका कॉन्जुगेट लिया. तो जब इसका कॉन्जुगेट लेंगे तो यही आ जाएगा क्योंकि इट इज रियल मैट्रिक्स. सो इट विल 16 8 0 16 and when we divide it by 4 we get it to be 4 2 0 and 4. ठीक है, this is what we started with xn. Okay, so this is right. Okay, properties of DFT. Some properties of DFT which will be important. Properties of DFT. Properties of DFT. These are important because it further simplifies our exercises of finding out DFT manually. Okay. So first property is conjugate symmetry property. conjugate symmetry property. Conjugate symmetry property. Conjugate symmetry property states that the xk, all the coefficients of xk, this means DFT, is equal to conjugate of n minus k. Okay. Provided xn, all xn belongs to set of real number. यानी कि अगर xn is real matrix, then xk will be complex conjugate of n minus k. Okay. इसको प्रूव भी कर सकते हैं हम, because what will be DFT of this? DFT of xn, complex xn, अगर रियल नंबर है, अगर xn is real, then xk can be written like this also. Agree? क्योंकि इसका complex conjugate will be same as xn. अगर xn is real, then इसका complex conjugate और ये जो है दोनों बराबर ही होंगे कि नहीं होंगे? So we can write xk as DFT of complex conjugate of this thing. Okay. So which can be written as n changing 0 to n minus 1, x complex conjugate of n, e raised to power minus j 2 pi by n, nk. Okay, this will be this. Okay, and this can be written as n changing n minus 1 xn and e raised to power j 2 pi by n nk, इसका complex conjugate. This thing can be written as, क्योंकि ये complex conjugate है, ये ले लिया और इसका उल्टा कर दिया. Okay, and we also know that it is periodic. E raised to power j theta is periodic, therefore we can write it to be like this also, n minus 1 xn e raised to power minus j 2 pi by n and n minus kn. Okay, क्योंकि multiplication by 2 pi n do not change anything because it is a complex. ये जो होता है repeat करता है अपनी values को. e raised to power j theta is same as e raised to power j theta plus 2 pi का कोई भी multiple हो, plus minus हो सकता है m, where m is integer. So using this property we can write it to be like this also, so it will be, और of course इसका तो complex conjugate है ही ऊपर. So by using definition of DFT we can write it to be complex conjugate of n minus n. Okay, this is called conjugate symmetry property. Complex conjugate property helps. How does complex conjugate property helps? Suppose we need to find out DFT for an 8-point sequence, and let us suppose for simplicity 8-point sequence is this: 3, 4, 5, 6, 7 and 8. This is xn. Let us suppose this is xn, and we need to find out its 8-point DFT. 8-point DFT. Third year, are you here? Third year?
Yes, sir.
Okay. So xk will be equal to summation 0 n changing 0 to 7, n minus 1 will be 7 because it is 8 point. Okay, xn and then e raised to power minus j 2 pi by 7 into nk, ये हो जाएगा. ओके, ये हो जाएगा. सो क्योंकि दो ही इसमें वैल्यूज, बाकी सब जीरो हैं, सो 1 प्लस सेकेंड वैल्यू विल बी e रेज टू पावर j 2 pi by 7 ओके एंड k, ये वैल्यू आ जाएगी. ओके, बिकॉज और सबकी वैल्यू जीरो है, एन की और वैल्यू जीरो है, बाकी सब जीरो है ना. ये केवल दो टर्म्स आएंगी, ये वाली दो टर्म्स. ओके, ऑफ कोर्स k इज चेंजिंग, हाँ पाई अपॉन 8, सॉरी पाई अपॉन. सो 0 1 2 and 7, k is going from 0 to 7. तो इसकी हमें 8 वैल्यूज ऐसे मिल जाएंगी, xk की 8 वैल्यूज बाय पुटिंग वैल्यूज ऑफ 0 to 7. So one way is to find out all the 4 values, all the 8 values. So let us first find out x0. x0 क्या होगा? x0 क्या होगा? x0 क्या होगा? इधर 0 रख दिया, so 1 plus 1 will be कितना हो जाएगा? 2. Similarly x1 क्या होगा? x1 will be 1 plus e raised to power minus j pi by 4, and it will be 1 plus 0.j minus 0.707, so it will be 1 plus 7.07 plus j 0.707, ये हो जाएगा x1. x2 will be 1 0 1 2 and 3, इन चार की वैल्यूज फाइंड आउट करके नेक्स्ट वी हैव टू फाइंड आउट और चार वैल्यूज फॉर 4, k इक्वल टू 4 5 6 and 7, ये चार वैल्यूज निकालनी है. बट वी नो दैट कि it is a real sequence, xn was real sequence, so we will be using complex conjugate property. And complex conjugate property क्या कहती है कि x of n minus n will be equal to xn, complex conjugate property कहती है x of k, x of k is equal to complex conjugate of n minus k. If can be written as complex conjugate of 3, so 3 का complex conjugate is this, 6 का complex conjugate is 6 निकालेंगे, 2 के complex conjugate से 7 निकालेंगे, 1 के